Well, good morning, everyone. Welcome to session 8. This is our final session for the season. Hopefully, you've all had a good. Oh no, I have to sneeze. It passed. It passed. All right. Hopefully, everyone's been enjoying what we've been presenting and learned a thing or two. We always like to introduce people to this industry, and maybe we'll see you out on a paving train or at a plant in the years ahead. So definitely don't be a stranger or don't be shy about reaching out to Jim, Scott, or I if you have any questions. Moving on in a career in this industry. Uh, but yeah, we'll jump right in where we left off last week talking about longitudinal joints. So we'll wrap that up and then we'll move into, general inspection, what you would look to do there, including density testing, quantification of materials, so how we actually calculate that. We'll touch on a random sampling method, and then we'll review some construction problems that are pretty common to encounter during construction. What's funny is, paving always seems kind of the same, right? We bring hot material, we run it through a paver, we roll it, but every project is different and you always encounter different types of problems. So we try and cover some of the more um, common ones. Anyway, this was the next slide after the longitudinal joints I was talking about last week. Density is the single most important factor in a pavement's life. You can have really high quality mix, beautifully reproducible, that's not compacted, and it will perform poorly. If you have mediocre mix that's compacted well and you get good density on it, it will be okay. So density is, we say it's the most important factor. And actually, for every percent air voids above our target, so we're saying greater than 8%, we expect to see about a 10% loss in life. So if you're expecting 10 years out of a pavement, which is a little short, but it's usually 12-ish, but it's easier to do the math on. If you have 10 years of service life you're expecting and you lose 10% from low density, that's a whole year off of its life. So just really quick numbers here. If you pay $1 million for your road and suddenly it's lasting a year less, that's a lot of money you just lost by getting low density. So you can see how this all ties into, the importance of our the desired air content we're looking at is between 3 and 8%, and it's controlled. The only time we can affect this is during construction. It has to be the right temperature, has to be rolled properly. So air voids between 3 and 8%, it's going to have high strength, the best running resistance, high durability, the longest performance we can get. And here in our state, the way it's specified, what the Connecticut DOT calls for is 4.5 plus or minus 2.5. And if you do that math out, if you do 4.5 plus 2.5, you get 7%. And if you do 4.5 minus 2.5, you get 2%. So that's our air void range. That's what they're looking at paving. So it's slightly different than the typical 3 to 8%, but that's how it's written into the contracts for state paving in our state. When we have higher air voids, more oxygen and more moisture are getting down into our pavements. And that oxygen is what's going to be breaking down our binder, making it stiffer or brittle faster. Um, with that water penetration, you also have a higher chance for moisture damage, moisture susceptibility, and you just have a greater pore pressure during freezing and traffic loading under saturated conditions, which can cause it to break down faster too. I mentioned this general loss of life as well. But this is a picture showing you here we had some segregated pavement. So more air voids, more open, lower density, and there's moisture sitting in there when the rest of the road is dry. In general, for any type of structure, when it's wet versus dry, it's going to be in worse shape. I think the only situation that might be different is for a reed on a woodwind instrument. You actually need to keep it moist to preserve the wood. When we have air voids that are actually too tight, it's called tightening when we have less than that, you actually have a chance of increasing your rutting potential. You could be crushing particles, so you're changing your gradation and increasing your fines. You also have a high risk of a condition known as bleeding or flushing. And what this is when the asphalt itself expands during thermal cycling and makes its way up to the surface. We chatted about that several weeks ago when we were talking about binder. But essentially what's happening is as the asphalt is expanding and contracting during the daytime to nighttime temperature changes, it's going to force its way up to the surface and reduce friction there, making it an unsafe driving condition. With super paved, dense graded mixes, it's very unlikely that we're going to overcompact them just because of the nature of their gradations. So avoiding rolling a mix because you're concerned about this usually is a little too conservative of an approach. In most cases, you can beat the tar out of it. Is that a pun? Because it's an expression about tar, but we're roads now. But anyway, you can hit a dense graded mix a lot with a roller and really never over compact it. So the chances are much greater that you're going to have a low air voids, low density, low density, high air voids. So that aging I was talking about, as we open up our air voids and allow more air in, that asphalt binder, the liquid, is mixing with oxygen, and the oxygen is just breaking down these really long hydrocarbon molecules that are in it. That's what gives it the flexibility of the liquid. So as those break apart, it becomes stiffer, and that happens in the presence of oxygen. Many things break down and fail in the presence of oxygen. A couple examples of that are rust on your car. If you happen to drive an older car like I do, once that metal is exposed, right, it starts to it's oxidizing in the presence of oxygen, and rust is forming. Another example of this, which is kind of different, you might not think about it, but fruit that is ripening is oxidizing. And right, there's a sweet spot for us to eat it, but eventually you're not going to eat it because it's oxidized too much. This process causes our pavement to crack. So in the case of our pavement infrastructure, that's the problem. We don't want it to crack. We need to limit those air voids to reduce the air going in and out. And we want to reduce the air voids until they're no longer connected. We call these interconnected air voids, where the air can really make its way down into the pavement and back out as a tire goes over it. And the tire is actually driving air in and sucking it out. That is most of the noise you hear when you're actually traveling on a road. To achieve this density, we need a non-yielding base. And what we mean by that is if you drive a truck over your aggregate that you're about to pave on and it's sagging down and leaving marks, then what's a roller going to do when you're driving down on top of a hot mat on that surface? It's going to yield as well. So ideally, what we're paving on is concrete or asphalt. That's the stiffest base we could be paving on. And you'll experience this if you've ever paved on a full depth construction where you're paving on aggregate. It's usually very hard to achieve density for that first lift. Once there's asphalt down that's much stiffer, it's much easier for the rollers to beat against that. And that makes sense, right? If you try to knead a piece of dough or Play-Doh on a pillow, it's not going to work versus putting it on a counter and pushing down on a countertop. That's the concept that we're talking about here. So when you're in the field doing inspection, you want to be monitoring density. You're going to be validating temperatures at the truck and behind the paver and during your roller positions. We talked about last week the breakdown, intermediate, and finish rollers. You're going to be checking the length, width, and thickness of the mat to make sure that it's the proper dimensions. And that also ties into the proper yield, which is how much material is going out. And then monitoring start and stop time of work, the weather conditions, and then other anomalies. And what we mean by that is strange things that don't look like the rest of the material or problems encountered otherwise. It doesn't have to be specifically related to the asphalt, right? If there is a motor vehicle accident in your traffic pattern, you're probably going to write a note about that too. So just as an example, it doesn't have to be specific to the pavement. So we had that slide already. Wait, is this showing up multiple times or am I clicking backwards? I don't know. I don't know. So we're going to monitor density in the field, and we've talked about coring already, but we do this several different ways. The first two items here, this is a nuclear gauge, which uses a radioactive source and measures photons coming back from it to determine the density. This other one here is called a ESCD, an electronic surface contact device, otherwise known as a PQI, performance quality indicator. It's a similar phenomenon, but it's using an electromagnetic wave. So it's shooting a radio wave into the pavement and measuring how much of it comes back and what changed about it. They're both indirect measurements, and they're decent tools. They're good for assessing quality on the fly, but there are blind spots to using both of those instruments. And we show coring here on the last picture because this is the tried and true method. The only real way to measure density is to cut a core. So that's actually how most of the time we're paying for the product. If you're on the acceptance side, if you're working for a municipality or a state, they're going to cut cores to determine the pay factor. But on the QC side, if you're working for a producer or a contractor, you can be checking during the operation how the process is going with one of these two devices. And just to give you an example, some of the problems with these would be the thickness of your mat. Depending on that, it'll give you different results. Also, if you're on different underlying layers. So like if you're on a milled surface and you move to aggregate, it's going to get different readings, even if your material is actually compacted exactly the same. So there's some issues with these that you have to be aware of if you're using them. And there's training specifically on that. But just know there's a handful of different ways you can actually measure density in the field. But the core is the ultimate item in that regard. Of course, with coring, we can't cut a core till it's cooled off enough after construction. And that's why it's best as an acceptance tool, because during the roller operation, you can't set up and cut a core for several reasons, right? Logistically, it won't work. So with quantifying the material, we need to know three things. Well, actually four. So we need to know the length, the width, and the thickness. Those three things I mentioned, that gives us a volume, right? Three lengths times each other is a volume. It's cubic, right? If you have one dimension, you have a length. If you have two dimensions, you have an area. And then if you have three dimensions, and I just happen to have this on my desk, you have an object, right? 3D, that's what we're talking about. When we're placing our material on a road, a roadway is a three-dimensional structure. So it's easy to calculate the volume. We have a target thickness we're constructing. We know what the width of the road should be, and we can measure how long we've paved in a given day. Now, the reason this is important is if we have a density of our material that we've gotten from a lab, right, we can actually figure out how many tons of material we put down there, or just check the tons that were coming in from the trucks. If you remember the truck tickets that are showing you how many tons were brought to your site, this is a good way as an inspector to double check that the scale is working right, or maybe something is off. It's just a good way to check out that everything's mathematically working. So here's an example of a yield calculation, and we don't have to go too far into depth on this because I know we have a short window of time today, but in this example, we have 800 linear feet and a 10-foot wide paving lane. We also know our target thickness that we're hoping to achieve is 1.5 inches in place compacted. We also were given from our plant that we have a unit weight of 155 pounds per cubic foot. Now, this would come from a bulk or maximum specific gravity that we chatted about a couple sessions ago as well. So we need to know that information. There are some other ways you can actually assume it as an engineer, or someone like a superintendent might, to figure out how many trucks they're going to need for the day, but you take on some uncertainty if you're making an assumption there. The other thing that's worth noting is because we talk about thickness in inches when we're paving a road, we need to convert that to feet. So we have feet, 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 right? If you multiply 3 units of measure, like inches and yards or miles and centimeters, they all need to match up or it's going to give you a nonsensical volume. And so what we do here is we take our 1.5 inches and we divide it by 12 inches per foot. And that gives us a thickness of 0.125 feet. Hopefully that makes sense, right? That it's 1/12 for 1 inch per foot. That's where that comes from. So now that we have all of our units in feet, we go 800 times 10 times 0.125. That's all of our feet from our site, right? We can actually measure those. And we get 1,000 cubic feet in this case. It's not a coincidence. I made this math work out easy. Now we take that and we know our 155 pounds per cubic foot. And if you look here, before we even do anything with this, I see cubic feet and I see cubic feet. I have a feeling those are going to interact, right? So we're going to take 1,000 cubic feet and multiply it across by 155 pounds per cubic feet. And I know it's a lot of math for the morning, but the cubic feet on the top and the bottom here are actually going to cross out, and our answer is in pounds, 155,000 pounds. Now, with paving, we happen to talk about mix in tons. So you do have to remember there's 2,000 pounds per ton. And that's the last step here, is to take our full weight, 155,000, and divide it by 2,000 to figure out how many tons we placed. So in that 800 linear feet of 10 feet of paving, it was 77.5 tons. Pretty cool. So hopefully your truck tickets actually match out with that and you can check and make sure everything is making sense. Any questions specifically on that one? I know I went fast and I apologize because I think I took too long last week, so I want to give enough time for all the content today. I'll pass it off to Jim at this point to cover some topics.
Okay. Thanks, Alex. And I apologize about sneeze. The sneeze you lost, I found right in the middle of that.
Yeah, I guess I did
It
transmit
just kind of happened.
technically.
Um, so when we're doing sampling, we want to use what's known as a random sampling method because we as humans have a tendency to bias the way that we would do things. And so by using a random sampling method, what we're doing is we're actually saying that any spot out there on the job or any ton of material that's leaving the plant has an equal opportunity of being sampled. And it's randomly done so that we're not just conveniently doing it when it's handy for us, because the reality is that we're all creatures of habit and we have a bad way of repeating ourselves. As an example, if you go into a classroom and there's not assigned seating or anything, wherever you sit on day one is more likely going to be the place you sit on day two, because we're just creatures of habit. And if you pay attention to that, you will notice that over time, and you'll just start to realize, hey, the place I sit on day one is a spot I'm probably going to sit for the rest of the entire semester or year. So we're all creatures of habit and we don't even realize it. So we use what's known as random sampling. And what we actually do is what's known as stratified random sampling. Um, Go ahead, Alex. Okay. Um, And some things that we have to look out for in terms of our quality. This may look like a really strange picture. This is a truckload of hot mix asphalt, but the plant malfunctioned and it loaded a boatload more asphalt binder in there than what it needed. And when you're out on a project, every once in a while, you'll get one of these truckloads that comes through, because the way that the plant works is it's based on scales and valves, and then this asphalt binder is very sticky. So occasionally the scale or the valve will stick and it will push way too much asphalt binder into it, and you literally get a soupy mess like this. We luckily don't see this as much anymore because the newer plants have cameras so that the plant operator can actually see the back of the truck when the material is being loaded into it. So it's less likely to happen these days, but it still does on occasion happen. And when that happens, it creates one heck of a mess that takes a long time to clean up. So this is just an example of something that can happen on a project. And if you are out there and you see that, obviously you don't want to let that go into the roadway because that's going to just be a disaster. So we don't want to do that. Go ahead. Here, when the truck is actually discharging into the hopper, sometimes material is spilled on the roadway. Over on the left-hand side over here, you'll see there's a small amount of material that's coming out around the tailgate of the truck and around the front of the hopper, and it's being dropped on the pavement. We want to try to minimize that. We can't stop it completely, but we want to minimize it because that material, when it drops onto the pavement, cools off very quickly, and it's not soft and pliable when the paver goes over it to strike it off. So we end up with areas of cold material that we can't compact very well. And nobody's going to remember 10 years from now why there's a pothole there. But a lot of times potholes are created by little things that happen at the time of construction that don't seem that important. And so therefore nobody remembers why that happened again, but it does show up. It will come back and it will be a problem later on. The picture on the right is actually, this happens about once or twice a year with a paving crew. A truck driver backs in and they start raising their truck bed before they're actually in the paver hopper. And so they actually drop that material on the roadway. And I've seen people panic when this happens and they think, hey, we'll just drive the paver through it and it'll strike it off. We don't have to worry about it. Well, the reality is that the wheels from the paver compact that mix. And when they do that, the screed can't strike it off because, again, it's kind of compact. It's already densified to some degree. So it ends up being a mess and then it has to be removed and replaced. And so when this happens, you just have to, you're better off just taking the time, clean. It's kind of like anything in life. If you take the time to do it right the first time, you save yourself time at the end of the day. when you're in a rush and you try to fix something fast, it usually goes bad and it takes more time than if you just did it right to begin with. And this is a prime example of that
Jim, does
image
that
on the
make
right.
that pile garbage, basically? Like,
That pile can actually be loaded back into the paver hopper as long as it's warm enough.
okay.
So you come in with like a front end loader or something, you can actually pick it up and put it into back into the paver. Sometimes though, it takes a long time to get the front end loader there and it cools off too much and then it does have to be thrown away. So, and this is a picture, this is one of my most favorite pictures of something that I collect, data imaging that we collected. This pavement is only 4 years old when we took this picture. Alex was talking about the importance of air voids earlier. Well, this was a pavement, it was 4 years old, and this thing looked like it was about 15 years old because of the fact that there were so many air voids in this pavement at the time of construction. In this particular spot where we cut the core, you can see that white stuff where the quarter, around the quarter, that white stuff is actually salt that was applied to the roadway during the winter. But the road is so porous that the salt is actually sitting inside the pavement structure and it's coming out in the middle at the end of July. And so when we cut a core out of there, what we found was the air voids were 17.2%. Using Alex's math of 10% per percent above 8, let's just say we had about 9% air void or 9% above that 8% cap. So we lost about 90% of the life of that pavement at the time of construction. So yeah, if you spend $100,000, if you spend $1 million on this roadway to pave it, well, you threw $900,000 out the window from day one. And to give you an idea how bad this paving was on this particular road, the paving crew actually had to take time and fill potholes that popped out of the roadway while they were paving it. It was that bad. So it was a horrendously bad experience. And the image over here on the bottom left hand is the core. We let that core sit on the countertop for a month and we weighed it every day. And every day it got a little bit lighter because it had so much water in it because it was so porous. And we used to that core was kind of like my little pet, and I used to bring it around with me everywhere. But unfortunately, it was so fragile after about 3 years, it fell apart. It just broke. And that was actually supposed to be 2 inches thick. And when you measure it, it was only about an inch and a quarter thick at its widest spot. Because it was falling apart so quickly. So that is kind of like, I can't find a better image or a better experience to show you the importance of quality during construction than that. Other things, and we've all experienced this, where manhole covers are set too high or too low, and we drive over them, and they're ba-boom when you drive over them. This was actually finished grade paving where the telephone company came in and reset the manhole covers before the road was paved, and they missed. And so this had to be, then they had to come back in afterwards and reset them again. So again, this is a problem and we want to avoid that. And so we want to be careful when we do it. Here's just a picture of a manhole cover where this is actually for a sewer where the town opted not to actually come and reset the manhole covers. And so the paving crew just feathered the pavement down so that they just kind of tapered it down instead of doing anything else. And after about 3 years, this is what it looked like because you had vehicles coming down, hitting that manhole cover, and then on the outs, when they were coming back out the other side, the tires are hammering that pavement and breaking it apart. And so again, this is a problem, and this is something that will cause the pavement to really perform poorly. So again, we want to make sure we do a good job when we do this. Other things that can happen. The pavement can be too hot. And I've seen this where the material was really the maximum temperature you want to see the mix at is about 325 degrees Fahrenheit. I've seen mix delivered to projects that was close to 400 degrees. When you're that hot, you're actually burning the asphalt. And when you burn the asphalt, it loses its stickiness. And so it's no longer gluing the aggregate and sand together. And so the road will fall apart very quickly. We can also have material delivered that's too cold. And if it's too cold, you just can't get that density. You get those high air voids like Alex was talking about, and you end up with pavement failures that way. We can have uncoated aggregate where the aggregate itself doesn't have asphalt on it. And you'll see it coming out of the back of the truck and it will literally not have asphalt on it in some places. And so you don't want to use that because at that point, what you end up with is there's no longer glue holding the stones together. So therefore, it will tend to fall apart very quickly. We can also have situations where it literally sounds like Rice Krispies when you add milk to them, where you get snap, crackle, pop. What that is that there's still moisture in the stone and the sand, and that snapping sound is actually the steam popping through the asphalt coating. And you can actually hear that out on a paving project. Again, something that we want to be aware of and try to correct before we place down thousands of tons of this material. And if we get a lot of smoke coming from the haul unit, there may have been diesel fuel that was used as a release agent. Diesel fuel is great at preventing asphalt from sticking to things, but the problem is that the asphalt will, or the diesel fuel rather, will recombine back into the asphalt, and you're basically dissolving the glue that holds everything together. And so while it's great as a release agent, it does nothing. It's not helpful to the pavement in the least. And if you've ever spilled like motor oil or diesel fuel on your driveway at home or anything, it will tend to soften up the asphalt very quickly and it can actually damage it pretty severely. So we don't want to use we don't want diesel fuel coming into contact with our pavement. Other things we can have is you can see in this image, you can see the cracking on the edges of this image. And that is an area where it's not supported. There's something going on there that needs to be corrected. And we want to make sure that we address that. We can have mixes that are so soft that they can't support the weight of the roller. And they'll actually squirt out underneath the weight of the roller, and you can never compact them. Those are what's known as a tender mix. And we can have checking where that usually happens later in the season, where the middle of the mix is warm, but the surface starts to get hard. And so as the surface begins to get hard, but the middle is still soft and squishy, like the inside of a nice, hot, warm chocolate chip cookie, the surface will begin to crack and you'll get cracking underneath the rollers. That's known as checking. And we can get over compaction, but as Alex said, that's probably the least of my concerns in life. If we had that happening more often, that would probably not be the worst thing. We can work with that, but over compaction can be an issue as well. Here you can see some roller marks in this pavement. They're pretty obvious, where the roller's cutting into the pavement and that creates problems. And obviously that's not a desirable surface because that's a weak spot where water and air can get in there and we can create problems in there as well. So this would be something that would be marked for remove and replace because there is no way to fix this. And there we go. As part of the remove and replace, they had to come in and mill that area out because that's the only way to replace it. Because like life, if you bury a problem in pavement, it comes back and it comes back pretty quickly, amazingly enough. And so just burying it under pavement it makes it look good for a year or two, but then it comes right back and it does nobody any good. And so depending on what you do in life, if you're working for a town or the state or a contractor, remember, burying problems never comes back to help you out. So let's see. Alex, you had said there were some questions or whatever, so I'm not.
Yeah, we had circulated questions with an earlier group, and these were some of the questions that they asked. So hopefully they kind of resonate with you. You want to alternate these or something, Jim?
Sure, if you want to take this one.
Okay. So question one is, as an asphalt technician, what would you say is the best part of the job? Well, I mean, neither Jim or I are specifically asphalt technicians, but having worked on construction projects, it's surprising, but the people are one of the best parts. Like you have to interact with a lot of people and you meet, nice people, all sorts of come from all different backgrounds, right? It's the state working with a contractor, a town working with a contractor, or a homeowner working with a contractor. The other thing that I would add to this is every project's different, and that's one of the things I really liked. Even though you might be running the same tests day in and day out, it's it's surprising what you'll see and find, and that keeps it interesting, I think.
If I could add to that, Alex, I think part of, again, as Alex said, neither one of us are asphalt technicians per se every day. But one of the things that I like about this job and this world that we live in is that as an asphalt technician, as long as you're doing your job and you keep yourself busy and you do what you're supposed to do, there's not anybody typically out there micromanaging your activities. There's a lot of autonomy as long as you're doing your job. That's the key phrase. You have to be doing your job, and as long as you're doing what you're supposed to be doing, that again, you kind of control the way that your day is going to go. And that's a nice thing. I mean, because there's plenty of jobs out there where there are people constantly in your face, constantly telling you what to do, and that kind of thing. And like I said, the key is that yeah, you can get away with not doing your job for a little while in the asphalt world, but after about 2 or 3 weeks of doing that, it comes back to bite you, and you won't be doing it. You will be unemployed. But do what you're supposed to do, and you will have a lot of autonomy to kind of do what you need to do when you need to do it, and that kind of thing. So that I think that I like that aspect of life. I don't like people in my face always telling me what to do.
One last piece that I was thinking of too is it's cool to have participated in like building infrastructure we all use, and it's easy to have pride in that type of work. I had a relative who washed windows, and he was so proud of the fact that he washed windows on the TWA terminal at JFK. Like that is, I think that's cool. And behind me is a picture of a project I worked on. I'm proud of the work I did there and on other projects I do. And I think most of the people in our industry really like that satisfaction of, building something and yeah, other people get to use and benefit from it. So that's kind of cool too. You want to
Okay,
start
I'll
this one?
I'll start
So
this
we
one.
can both chat.
Yeah, we'll make it a little church chat here.
Yeah.
Uh, I know that's lost on everybody here because you guys never. That's a Saturday Night Live skit from a long time ago. Um, but can I be an asphalt technician as a summer job? Yeah, you certainly can. Companies are willing to take on interns, and you can start to get some experience, and you can start to learn what about the job and what it entails, and if it's of interest to you. It's so yeah, you certainly can do that, and there are companies that are willing to let you do that.
We actually just trained some people in a half day session last week for a company that um, hired them during college. Their email addresses were from college. So even if you're not in college, it's a great summer job. But yeah, it's seasonal work in some ways, right?
I know
What we
that.
mentioned. Oh, sorry.
No, that's okay. I didn't mean to interrupt you. I was going to say Huda, one of our previous students, did an internship at Tilcon for the summer, and then went to college, and they asked her to come back the following summer. So yeah, I would say
Yep.
definitely.
These
And
companies, no matter how big they are, all notice if you work.
Yeah.
right.
Yep.
And the other thing that I'd like to add to that is that most people in the asphalt industry never started out with the intention of making it a career, but it's a place that people go, and most everybody stays. I mean, I will tell you that when I was in school, I did not intend to get involved in asphalt. It didn't seem that attractive or exciting to me. But the reality is that there's so many things that I like about it that once I started, it was like, hey, this is a really cool opportunity. And so by doing a summer internship or anything like that, it really gives you that opportunity to understand what's going on and kind of get the flow of how it works. And you can see for yourself whether it's for you or not for you.
This is a longer question. How has the
Okay.
HMA contents changed for environments with extreme weather? Example, Phoenix, Arizona versus northern Alaska. And if the temperature could be the same every day, what would be the best temperature for the asphalt most common in Connecticut? Wow. Could write a paper on 2 or 3 different subjects in there. So the biggest difference, really, we could use the same aggregate everywhere, but trucking aggregate across our country is obviously costly and environmentally damaging. So um, our aggregate varies region by region, and because of that, we do change some of the additives, but the biggest difference is the liquid asphalt binder. If you recall from our binder session, when we talked about like the PG grading and how it's named for the high temperature and the low temperature, that's going to be the biggest factor there. Anything else you'd throw in there, Jim?
No, I mean, in terms of the best temperature for the asphalt, most common in Connecticut would be if we could prevent the highs and the lows and just have an average temperature of about 60 degrees day and night for 365 degree days a year. Life would be, the pavement would love it. But
I was thinking like cold might be best, but then you'd eventually hit your glassy transition, right? And it would become embrittled.
yeah, but
It's a
like
really weird material, and that's honestly one of the things I find interesting about our field is liquid asphalt binder is absolutely insane.
I have a
It's
question to that
yeah.
question. Are they asking what's the best temperature when they're laying the asphalt or just in
Hmm,
general? Like
that's a good
the air
question.
temperature.
Well, during construction, almost the hotter the better. Oh, sorry.
no,
But
no. I mean, well, to a cap. I mean, we don't want to
yeah,
burn the asphalt. So
I
uh,
mean ambient.
oh yeah, I've not. Hmm.
I don't know what they're asking. Actually, it's a good. We should also say if anyone listening in right now has questions, feel free to chat too. Um, Otherwise, we'll keep answering these ones. The best temperature, yeah, I don't know. There's definitely a production temperature cap.
Okay, yeah, I'm not sure the best on that one.
Yeah,
What does a typical day look like? Well, obviously, if you're working in the, let's say, the plant in the lab, you're going to come in. The first thing you're going to do is make sure that your equipment is turned on, warmed up. You're going to have an oven, make sure the oven is hot, that kind of thing. And then what you're going to do is you're going to figure out when your random samples are going to fall. And that's when you're going to pull samples from trucks. And that's going to be material that you're going to do. And typically, you're going to do 3 to 4 sets of random samples in the course of a day. It could be 5 if it's a really high production day, but it's usually going to be 3 to 4. And so then what you're going to do is you're going to grab your random sample, and they're going to be spread out throughout your entire day. So the first one you'll get somewhere in the first hour or two of your day. You're going to then bring that in. You're going to test it. You're going to compact your samples. You're going to make your maximum theoreticals, so on and so forth. And then you're going to kind of do that again over a couple more times throughout the course of the day. You may also run samples from, let's say, the aggregates just to make sure the gradations are holding it in the range that you expect them to be, and things like that. And you may also be doing moisture contents to do corrections for loading the plant, because you have to know what the moisture is in the stone and the sand so that you can adjust the feeds into the plant, because once you dry it, that material that obviously the moisture goes away, and so you need to compensate for that.
there also could be like cores coming back from the field, and you'd be coordinating with a field technician and testing those as well. But there's usually a lot of phone conversations between yourself, the plant, and the field, uh, just making sure everyone has the right information. It's a little cheesy, but knowledge is power. So, like, if you're on the contractor side, the sooner that you know your lab results in the field, the better the quality is going to be there. So, you work hand in hand with those people to make sure they have the tools they need to make decisions. And I feel like there was one other thing I was going to say, but I forgot it. The next question is this one's always my favorite. What is the best way to repair a pothole? Well, the best way is to rip your entire pavement section out and pave it with a paver. And you'll actually encounter this with utility trenches. This is one of my biggest pet peeves is utility trenches because they want to do the smallest amount of excavation to get to their utility, whether it's a wire or a pipe, and put material back in. But for us, for our industry, for the pavement, the best way to repair a pavement is with a mechanically spread asphalt. That means wide enough for a paver to fit in. So I would always correct details when I was doing designs and make them wider, at least on the top layer or layers, so a machine could actually place that material. But at a minimum, you have to excavate down to the offending material. So there might be several layers you would have to excavate down through. Saw cutting joints is important, so having square edges, cleaning it properly, and then compacting it in multiple lifts with hot material. That's the best way to make it last. One thing, and we've had a lot of conversations with municipalities, is a pothole repair. Any repair is only going to last 3 to 5 years. You can expect it to last that long. If it lasts 7, fine, but you can't expect it to last 8, 10, 12 years patching a pothole. There's a good chance that the material around it is also going to be not great.
In addition to that, what I would add is that unfortunately, potholes happen at a time of the year when most of the hot mix asphalt plants are not open. So we have to have ways to be able to try to, I'll say, limp along to be able to get to that point where they are open so we can do the permanent repairs. And so one way that we will put what's known as cold patch in the potholes. That cold patch is not the greatest material in the world, but in February, it's about the only material you have available to you. There are some ways that people have come up with to do permanent repairs. The DOT uses it, as well as some municipalities have access to it. They're known as pothole patchers. These pothole patchers, they actually spray hot liquid asphalt into the hole, and then they drop stone into them so that they have a better chance of surviving and actually not popping back open a couple days later. Because with cold patch, it tends to just pop back out a couple days later, whereas with the pothole patchers, they are more likely to last a longer time. And some of those will last for several years, that kind of thing. So that is another way to repair them. It's obviously what Alex was talking about was the best way possible, but sometimes we have to do less than we don't have that option because of the time of the year. So
This is an example of one of those machines. They're pretty cool. They're all self-contained, and the driver, I think it's a one-person operation, right? So you don't have people standing on the road in adverse conditions.
Yeah, there's the ones that are like that,
Snorkels.
and then there's also the tow behinds, which you
Oh
can
yeah, yeah.
past. There are
They're
so
pretty expensive machines.
yeah, but if you've hit enough if you hit a pothole and it bends the rim on your car, you will greatly appreciate the cost of those machines.
Yep, yep. And it really is pennies on the dollar to the whole piece of infrastructure. And
Let's see.
oh, oh yeah, this is you. Sorry.
Can this lead to more than just asphalt jobs? And the answer is most definitely yes. These companies some of them are very large. Some of our global companies. As an example, Tilcon is owned by a global conglomerate. And so they have needs not just in Connecticut, but all over the United States and all over the world. And so a lot of people enter this industry. You kind of start out doing some technician, some testing, some inspection. And again, how diligent you are and how willing you are to work will really translate quickly as to how fast you're able to move up through these companies. And so you can move up to a supervisory position. You can then move up to a QC supervisor. You can lead up to a superintendent, so on and so forth. So there's a lot of different jobs out there that this goes to. And also these companies also do a lot of other work. As an example, like O&G, they do asphalt, they do concrete, same thing with Tilcon. So if you wanted to get out of the asphalt world and go over to the concrete world, and you showed that you're worth on one side in the asphalt side, they'll happily take you over in the concrete side or field, whatever it happens to be. If you're doing vertical construction, if you want to get into that, again, if you show your diligence and willing to do things, they all, like O&G does a lot of vertical construction. And so they're like, that's bridges, that's buildings, that's things like that. So they're willing to take you if you've kind of cut your teeth and demonstrated your worth.
With these bigger companies too, if you're good, they will send you where the work is. So this one picture on my back wall here, they shipped a crew up from Texas. They're all in hotels for the entire project. They have company vehicles. So there's a lot of exciting opportunities when you demonstrate that you're a valuable asset to that company. And with respect to, like Jim was saying, there's vertical construction. There's concrete, there's pumping concrete, there's pre-stressed concrete, there's precast concrete. So there's all different fields, even within concrete or asphalt. With asphalt, you could tend towards the liquid side and become a binder technician and go work for a terminal. There's a terminal in Deerfield, Massachusetts. There's one in Rhode Island where they're actually getting asphalt, blending them, mixing them with polymers and testing them. So there's a whole variety of different ways you can take this besides just the working at a plant for sure. I'm getting all these practical questions. When should I seal coat my asphalt driveway? Um, Honestly, I would say earlier than you think, but also it needs to be dry. Do you have any other thoughts on that, Jim?
Yeah, I mean, it's one of those things that driveway sealing is not a bad thing to do. But yeah, usually it's probably in the 4 to 5 year range, is when you're going to get the most bang for your buck for doing it. If you wait
Yep.
too long, it makes it look good for a year until next winter, but it's really no more than just taking and painting the driveway black.
Yeah.
Um,
You want it, it shouldn't be a repair. What its purpose is a sacrificial layer. So it'll
right.
preserve what's underneath it.
And help to prevent water and air from getting into the pavement, for reasons we've already talked about.
Yep.
How many mixed plants supply asphalt to Connecticut? It's over 30. It's 30 to 35 plants, depending upon the year. And occasionally it's more than that, because some companies choose to bid on Connecticut projects, and then some years they choose not to, depending upon what they anticipate their workload to be. So for a tiny little state, think of Connecticut as a rectangle. That's 100 miles wide and 50 miles tall. That's 30 to 35 mixed plants just for our little tiny state. We're the third smallest state in the country. So there are a lot of plants out there and there's a lot of needs. So
And
there
a
are
lot of the
plenty of
companies in Connecticut have overlapping plants in nearby states. So even if you're working this year in Connecticut, they would probably say, hey, how would you like to go to Massachusetts for the summer or go to Maine for the summer? There's a lot of opportunities like that too.
it's rare you're going to run out of work. It's very rare.
That one picture you saw where the pavement got removed after the roller marks, that was a project I was on. They sent me to New Hampshire for 45 days. I was building a runway up there. A good example of traveling for work. Question 9. Is it difficult to consistently produce high quality asphalt? In some ways, yes. In some ways, no. It requires everyone paying attention. And there's close to 2 dozen people from the quarry to the last roller operator to make sure that this goes well. So in a sense, it is difficult because, that's a lot of people to wrangle personalities and, things that could be affecting our work and our day. If someone's having a bad day and they're not focused on the work, yeah, it might be impacted by that. And there are many points along the way that it could go bad. But by and large, if everyone's paying attention, there's no reason why we can't produce really good quality material.
And I'm going to add one little thing to this because this is kind of my mantra of life. You'll always hear people say that, oh, 100 years ago, people knew how to build whatever, furniture, houses, whatever. But there's a reality here, and that is that there was an awful lot of poor quality construction that went on 100 years ago. Um, what do we see today? We only see the best of the best. All the other stuff was torn down, burned down, ripped down, fell down. And so all we see now is the best of the best. And so as we go forward, I always tell people my goal is that I want people 50 years from now, 75 years from now to say, wow, those guys in the 20s, early 2000s really knew how to build stuff. And that's my goal in life, is to have that happen. I won't be here to hear them say it, but um, I want to actually have that somewhere in the back of my mind that that's what they're talking about. Okay. What is the strangest HMA that you've worked on, and how was it different from regular HMA? Wow. That's an interesting question. There was one project that we worked on that no matter what we did, we could not get it to compact. I mean, we tried everything under the sun and it would not compact. We couldn't get it we couldn't get the density down to where it was supposed to be. They tried producing the material really hot. We had two rollers going basically side by side up and down the road. Nothing would compact that material. And it turned out there was a chemical reaction going on between an additive in the asphalt binder and the asphalt binder itself that was causing this problem. But of course, we didn't know that at the time. And so as this, I mean, I was out there for weeks on end trying to figure out what was going on. And it turns out it was something way beyond our control. But ultimately, amazingly, that pavement is still out there. I'm not going to tell you where it is because I need to protect the innocent here, but it's still out there. And for all the reasons that we've talked about, it should never have survived more than a couple of years. But this is one time where everything else has gone well, and it's been out there since 2011. And some of you have driven across it, I'm sure. And it's still down, and it's still in reasonably good shape. So every once in a while, what's the saying? The blind squirrel finds a nut. Well, this was one of those cases.
So, a couple parting thoughts here. Um, working in the asphalt industry isn't for everyone, and that is okay. That's partly why we ran this program. It's in everyone's best interest, including yours, to know what you're getting into. I always, right, when you go buy a car, if anyone's had this experience, you test drive it. I've always wondered why when you buy a house that's not brand new, you don't get to sleep in it before you buy it. I think that's weird. But we're like we're letting you try the shoes on here, so you hopefully have a sense of what you're getting into before you show up on day one, because we want you to like what you're doing. But dependability, if you haven't guessed, is really critical. There are 24 people, right, relying on this to go right. If you don't show up because you were out partying the night before, that's a problem. Um, you do have to put in your time and pay your dues, and it will pay. Like everyone notices good workers, and they do get rewarded, especially in construction. There's lots of money for bonuses and finishing projects early. So if you are one of the people who have enabled that to happen, we're talking like hundreds of thousands or millions of dollars in bonuses on some of these bigger projects when they finish early. And people get rewarded financially and with better positions. And yeah, you kind of can reap what you sow there. You do need to pay attention and learn things and be quick to learn things and go the extra mile. I always tell students working in our lab, always be cleaning, ABC. If I go out and I see people on their phone instead of dusting, like that doesn't show someone taking initiative, and I have to go tell them the next step to do. And then, with infrastructure, details matter. That spillage out of the back of the truck makes a pothole, right? That's something that's easy to ignore during construction because you've got 14 other things you're thinking about. But if you go the extra mile, it does pay off. And yeah, if you treat this just as a job, that's okay if that's what you want to get out of it, but don't expect to progress, right? If you want to just show up, run tests, and go home, that's totally okay. And we do need people like that in the industry. It is helpful. It's not detrimental. But if you like it and you want to put in the effort, you will get rewarded in multiple ways, I'm sure.
So
that's our last slide here.
Yeah, no. So hopefully, if you guys choose to enter the asphalt industry, we're going to get to see you guys at different trainings. You'll see us for sure. We're kind of, we turn up everywhere. So we are happy to see you guys. We're happy to ever answer any questions. We're always happy to try to encourage people and help them progress in their careers. And that's kind of what we do. So we appreciate your time and attention to us through these last 8 weeks. I know doing this virtually might be a little bit challenging, but it allows us to have multiple schools and multiple people from all parts of Connecticut involved. If we were just going to one facility, we wouldn't be able to have as many people involved in this as we do currently. So we do appreciate that. If anybody ever wants to take a tour of our lab or anything like that, obviously reach out. I know one or two of you already have reached out, which is great. We hope to do that more. And if anybody, and again, we encourage you guys, and anything we can do to assist, we are happy to do so. Alex, any parting thought? Any additional thoughts?
No.
I'd just like to say thank you to you guys, to Jim, Alex, and Scott, for coming on and doing this program. I know some of the kids are definitely excited and interested. And to those of you that are interested in this as a career, or you just want to continue to pursue it, please send me your email. I'm sorry, send me an email with your resume. Because I do have companies already asking, um, you know, for me to send them resumes of the kids that were participating in this program. And the other thing is that we can help you with your resume. We'll have verbiage to add this program onto your resume. Um, and just, yeah, thank you. This was a great program. And let us know if you're interested in doing a tour, either at the lab or at one of the asphalt companies. We have had a couple people say that they would be interested in hosting a tour. So touch base with me, and we'll make that happen. Thank you, everybody. Oh, those of you that have not done quiz 7, you can
Oh
now
yeah,
do quiz 7.
I forgot about that.
And everyone should send me your resume. And I think that's it.
Okay. Well, thanks everybody.